companies expand to the cloud, asset visibility worsens. The Jupyter One Cyber Asset Management Platform helps you get it back. Jupyter One provides context, understanding, and visibility into your entire cyber asset attack surface. With over 150 integrations, including AWS, Google Cloud, Azure, and more, Jupyter One helps you answer complex security and infrastructure questions, understand the contextual relationships between assets, and build the foundation for your security program. Try it for yourself. Get started with your free Jupyter One account today.
This episode is sponsored by Hunters. Hunters is a SOC platform that ingests data from your IT and security tools and applies a built-in detection engine encoded with hundreds of TTPS, attack methodologies, and threat intelligence. Security teams use Hunters to reduce mean time to detect and respond by automatically investigating, correlating, and prioritizing suspicious events. Combining Hunters' SOC platform with Snowflake's data lake can help your security team achieve greater coverage at a predictable cost and mitigate threats faster, more reliably than a SIEM. Visit hunters.ai to learn more. Hello and welcome to another episode of Cloud Security Podcast with Virtual Coffee with Ashish. Today is the first episode for AWS Security Month, and we wanted to try something different. And I think when I say different, it's not like, I'm talking AI machine learning. Let's just say that. It's not the metaverse yet. Maybe AI machine learning to begin with. And for this, I was lucky enough to have someone local to myself, Australian, who is an AWS Hero as well. And I'm not going to spoil his intro, but I'm definitely going to bring him on with, I guess, a British classic, as it's called out in the playlist. Hey, Mike, thanks for coming in, man.
No worries, Ashish. How are you doing?
Good, man. Good. Thanks for coming in. I feel like I guess a British expat in Australia deserved a British classic. So
Thank you very much.
That you allowed me to do that. We've got a few more people coming in as well. So hey Vineet, hey Rama, thanks for coming in, guys. So it's an interesting one. Before we dive into it, thank you. I don't know what you got. I've got coffee here. I don't know what you got, man.
I am drinking tea. I think
tea.
Most people that follow what I do, I end up drinking tea pretty much no matter what time of day it is. So this is me drinking tea. A local blend, I have to say. So it's from about an hour south of here over the New South Wales border. Nothing particularly special, but one of my favorites.
All right. Okay, cool. Mm-hmm. Well, by the way, Pedro liked the intro song as well. Hey, Pedro. Thanks for coming.
Yeah. It's slightly strange, but then I'm slightly strange as well. So that's fine.
Yeah. All of us kind of are. Okay, maybe it's a good point to kind of get into, because I know for some time. I guess some people on the stream already know you for some time. For people who may not have heard of you before, so how did you get into the whole AWS Hero, machine learning? What was your entry into the space?
Wow. That's like the entire podcast right there. All right, where do we go?
Maybe like a 30-second version. There you go.
Yeah. Okay. Sure. Okay. So my name is Mike Chambers. Hello. I'm into machine learning, into AWS, and yes, I was very, very fortunate to be invited into the AWS Hero program, which sort of pops me up onto people's radars, I guess, so that people know that I'm doing this stuff. So I've been producing training material and online stuff and YouTube stuff and live streaming stuff about machine learning in AWS and all kinds of stuff for quite some time. And AWS kind of, they support me in what I'm doing. I don't work for AWS, but they support me and they help give me connections into places and tell me little secrets about what's coming up in the future and things like that.
Sweet. So which is where the whole AWS Hero kind of comes in. So you're the AWS Hero for machine learning and AI.
Oh, I am one of them. I'm not the one. I'd like to be one, but I am one of them. Yeah. So there's a few of us around the world. So each quarter, I think it is, they reach out to people in the community that they've seen who are doing, outreach to the community and talking and blogging and all that kind of stuff. And they invite you in. It's an invite program. And so, I was fortunate enough, year and a half ago, maybe, I don't know. It's been a whirlwind to be in this program. Yeah.
That's awesome. And I think it's probably a good segue into my question as well, because I think a lot of people always get confused with AI ML. I would love to say that I know what AI ML is, but Tom likes your song as well. We should all have great walks and songs like Gorillaz. Gorillaz is a great band, man. Cool. So there you go. I think we can talk about the intro song for the next few minutes as well.
Yeah, let's do
But
that.
yeah, so AI ML, what is
Even
it
is it?
for people who don't know? Because I
Yeah.
imagine people hear a lot about it. What does that mean for you?
Yeah. Okay. So let's park AI just for a second, because that's a very difficult term to define, because it hasn't really been officially given a definition as such. People
Right.
could argue against that. Machine learning, that is something that we can definitely talk about what that is. And unhelpfully, maybe to start with, it's the closest thing as a data scientist or a an IT professional that you'll come to being something like magic. Like, it is amazing. Like, it's the ability for computers to learn. It genuinely is that. Now, it's not actually magic, and we do know how it works, and obviously we apply it to things in our day-to-day lives. Under the hood, what is it? It's the ability for machines to recognize patterns in data. That's far less exciting than to say it's like magic. But yeah, we're all kind of familiar with the different kinds of use cases for machine learning. But under the hood, what it's doing is it's just recognizing patterns in data and learning from that.
Right. And so AI then is, because it doesn't
Yeah.
have a definition,
So
why do people keep saying they have AI?
Well, so AI it's more of a pop culture kind of term, really.
Right.
It's I mean, artificial intelligence. Like, if you went 20 years ago, 40 years ago, and talked to people about what AI was, because it was still a term that was being used back then, people would just look over the horizon of what was technically possible right now. And so you'd you know, expert systems. I don't know if any of us remember expert systems, where essentially the computer was able to take inputs and say, really, there were if-then statements, but just lots of them, and say, well, if you've got this, this, and this, then you must be a one of these. Like, it's relatively simple by today's standards, but way back, that was amazing that computers could do that. And that was sort of seen as the emergence of artificial intelligence. And people have been talking about this for ages. Now, people talk about artificial intelligence being, again, over the horizon. This idea that Black Mirror comes about, and we end up with sentient machines and things like that. So now, that's not to say that it hasn't been turned into and used as a marketing term, which it absolutely has. But really, truly, I think artificial intelligence is just this unattainable goal that we're constantly striving towards. And I quite like that, because we are constantly moving forward with machine learning and constantly achieving new things. So it fits in the world, but machine
Right.
learning really is where the driver is.
So the business use case examples that we see all around us, they're technically machine learning examples rather than AI examples. Is that right?
Yeah. I think if we're seeing actual practical things that are actually happening, obviously we know how they work, and they are based in real science and real data. And yeah, that's machine learning. Yeah.
And what's a good business use case for, I guess, where do you see people use machine learning quite a bit, I guess?
Sure. Well, gosh, everywhere. Like, it's an enormous subject, and I think that's one of the things that we need to sort of address right up front as well. It is an enormous subject, and we'll probably come back to that a few times during this discussion. It's used all over the place. It's used in places that you probably are quite familiar with. So Home Assistants, Google, Alexa, and all this kind of stuff. And I've already pressed the mute button on mine, so it didn't trigger when I said that. But doing the voice recognition, but also doing the sentiment analysis and understanding the language of what you're asking for. There's kind of very palpable, in front of you examples of what machine learning can do. But also things like recommendation engines, things sending you, well, you've bought this, you might also be interested in that. But then fraud detection and getting into other sort of more behind the scenes kind of stuff, medical applications where they're making medical diagnosis from data. Where everywhere it is applied in many places, and it will eventually be applied pretty much everywhere.
Right. And I think to your point, because even there are subcategories within it, right? I think the whole Alexa Siri thing is, I'm just trying to make sure my doesn't wake up as well. It's like natural language processing, right? And to your
Yep.
point, at the almost at a 10,000 feet view, they're all just doing if then statements, I guess. Would that be right?
Well. So I think that's a little unfair on machine learning. It's a bit more than that. So yeah, you've got different categories, like you said. So you've got natural language processing, you've got image classification, image recognition, that kind of stuff. You've got clustering, you've got classification, you've got lots of different types of things. At its core, and the reason why it's different from regular development. So let's say regular development is if-then statements. The reason why it's different to that is because what we do is we get the computer itself or an algorithm to write the code for us. So let's stepping through a simple sort of scenario and maybe get some terminology right. So half the battle with understanding any topic, right, is the terminology. And so let's get a few terms in play. 100%. So we start out with data. And we call that training data. That training data then is, it's a wealth of data that we already have. We then take that and we provide that to an algorithm. An algorithm is a piece of code that a data scientist or machine learning engineer has already written that knows how to look for patterns in that data. That process of the algorithm that the algorithm goes through is called training. It does a training process and it produces a model. And the model essentially is a piece of executable code that will do the thing that we need, but we didn't write that. The algorithm wrote that. That's what's really exciting about this. The algorithm wrote this model. Broadly speaking, we might not even know how that works, but we know that it does work and we can use it. So we don't look inside that and go, oh, there's the if-then statement or whatever, anything like that. It's like, it works, good, excellent. Right, let's move it into production and use it to recognize someone's voice or recognize an image or do something like that. And that's the kind of magical feeling part of it, is there's something in there that works, and that's really exciting. I don't know how, but it's awesome.
It's just interesting because I think, as you kind of mentioned it kind of reminded me that when we were trying to work on an ML project, we had the whole conversation about supervised learning and unsupervised learning as well. There's a few more layers to it as well, but I think it's an interesting question that just came from Vineet as well. I think I don't know. So as machine learning uses patterns of data for prediction, how can we address risk of privacy from security point of view?
Okay, yeah. So very interesting topic. So there's two different sides. There's two different parts to that I think are interesting. You've got both the training side of things, so the data required to do the training of the model in the first place, and then you've got the inference side of things, making inference from new data. So making a prediction. So both the start and the end both has this touch point with data. So from a privacy and security concern, let's say at the far end, like when we have our actual outcome, then largely speaking, the way that we would deal with that is very similar to any other kind of application, because at that point, it's an application that's running. Now, we didn't write it, but it's an application that's running. So the data that's coming into the system, we would need to secure like any other data that's coming into a system. So I think that's fairly well understood. On the other end of the spectrum is where things get a little bit more interesting. And also there's some ethics questions that come in there, which are related, I think, to this. So in a normal, let's say a mainstream, I don't know what you call it, non-machine learning workloads, like the kinds of stuff that, the if-then statement. I like how we're coining this. The if-then development cycle. Let's say we can keep developers away from production data. Like I like developers, don't get me wrong, some of my best friends are developers, but we essentially keep developers away from that data because they don't want to have to think about the security of the data they're playing around with. They just want to write code. That's their focus, is to write code. Right. So we remove that need for them to be, in a highly secure environment or whatever. With the machine learning problem, that's slightly different, right? Because data analysts, machine learning engineers, they kind of have to work on production data to make the model. So there are some concerns around that and sort of providing secure environments. How can we do that? I think probably one of the prime ways is by making online and cloud environments for them to be able to do that work. So we don't tend to as much do that work in a local environment, pulling down vast data sets, very valuable and sensitive potentially data sets to local development environments. We do it up in the cloud somewhere. And it also makes sense because we're talking about vast quantities of data. So just from an efficiency point of view, that works out as well. You then also have this sort of ethics question as well. And this is where, do you actually own the data that you're building a model from? If you don't own the data, is that ethically and legally problematic? And there is lots of questions which are way more complicated than I'm qualified to talk about, but they are very front and center to huge discussions and debates in this area as well. So yeah, lots of things to talk about there. But from a security perspective, I think the prime thing is get the development up in the cloud somewhere.
I think just to add to that as well, by the way, great examples. I love the answer that you gave, because to your point about the normal if-then, I'm going to use that statement as well.
Yeah.
The regular if-then development life versus the algorithm building machine learning life. So in the if-then statement, there's a lot more controls you find. There's a lot more data access kind of conversation that have happened for years. With machine learning, I think it's an interesting set, because one of the projects that I was involved with, I remember we spoke about masking data, like, hey, mask my name, mask Mike's name, mask Vinny's name. But unfortunately, machine learning sometimes doesn't work like that, because to your point, I mean, and you can correct me if I'm wrong, obviously working more in the space than I am, from what I was told, the algorithm kind of for it to understand the data properly, it requires a good data set. And I mean, we can go into the whole data cleaning side of separately, but I think it was really interesting to hear that if you mask the data, it doesn't know if it's Mike or Ashish. So next time Mike or Ashish comes in, they just come as numbers. But I don't know if that actually is like the other side where, well, to prevent privacy loss or lack of privacy, you can mask data if you want to, but then your algorithm is kind of like pointless because it's working off numbers. It doesn't work off real information. So curious to hear your thoughts on that as well.
Yeah. So what you're saying there is absolutely correct. Now there's a deeper level to that as well, but you're right. So let's think on let's put a scenario in place where we're not talking about images and all that kind of stuff. We're talking about tabular data, fraud detection. So with fraud detection, a bank will have vast quantities of transactions that they already have. They will have, some of them have already been flagged as fraudulent because they have been doing this business for quite some time, and they know what they know some transactions that have been fraudulent, but they don't really know how to be able to spot them in the future. And that's because when you look at it, it's got loads and loads of different data points in it. Each of those records that represents both fraudulent and non-fraudulent have got many data points. And there will be things like someone's name and their address and the time of purchase and the amount of the purchase and what they purchased and all this kind of stuff. Now, when you put it, and so we would then label that data, and that comes to your point with supervised training, by the way. So that's what supervised machine learning training is where we have a data set where we already know these examples, and we want the computer to learn what that looks like so it can detect it in the future. Now, when we as humans look at it, we might bring our own biases to it and all kinds, but essentially we can't really see the pattern because we're human and we're flesh and we're flawed things. We're not purely statistical in our analysis. So we want to get the machine learning to do it. That's the bottom line of a supervised machine learning problem, and that's what fraud detection might look like. Now, to talk to your point about masking of that data, and machine learning projects in general, is you need to get domain experts involved, people who actually understand the data and also understand machine learning, honestly, to be able to help with that kind of thing. Now, in that particular case, taking that person's name and masking that, or even completely removing it, is probably okay. And ethically, that's probably the right thing to do as well. If we start to say, well, if you're called Frank, then you're more likely to be, fraudulent, then there's probably something wrong with that. It doesn't sound right. I'm not an expert in fraud. But take their address out of it, well, maybe that starts to be something slightly problematic, because you are talking about, was this transaction made in Scotland by someone who lives in Frankfurt? Like, okay, so address does matter, and not to mention, all the socioeconomic and all the other kinds of stuff as well, potentially. So you kind of do need that. Probably, again, not a fraud expert, in order for the algorithm to be able to actually make the right kind of determination. So that's the sort of the illustration of why anonymizing data or masking data isn't necessarily going to work.
Oh, and I think, sorry, and this was a good point as well, because as people who are listening to this episode were kind of ponder on the idea for, what levers do I have to pull from a data and privacy perspective as well, whether it's data access or whether it's the context of, do you really need my first name, last name, my address? To your point, use cases may vary. Like maybe a fraud intelligence person may require it, but I don't know. I'm just trying to think of an example where recommendation engine may not need it.
No.
Especially if you're just saying, hey, you bought this t-shirt, you probably should buy this trouser as well. So it doesn't really require my address and my name and everything, but it may be happy with me being a number. And it just might be a recognition for people who usually bought a t-shirt have also bought this pants as well. So maybe I'm just not, I don't care who your name or what your name is or who you are and where you're from, but this is the statistics saying that 9 out of 10 people who bought this t-shirt have bought this pant, bought this trouser as well. So most likely you would like it. Is that a fair simplification of it?
Yeah, maybe. But I mean, and again, I mean, I'm interested in trying to pretend to be the domain expert in some of these business scenarios that we're coming up
I
with.
don't consider
But
myself a domain expert.
yeah. But as in, you know, I don't know so much about the retail space. I mean, obviously we can make educated guess, but like I'm not an actual expert in the data of the retail space. However, you could imagine quite really that people who have bought this t-shirt who live in the northern half of your country might want to buy this. And people who buy this t-shirt who live in the southern part of the country, where the weather's different, might want to buy something different. That's absolutely a thing. I could imagine that's a thing. So then maybe the data masking side of things is slightly more nuanced than that. And maybe we deal with data pre-processing. So there is a conversation to be had about the data cleaning and data pre-processing maybe happening in a separate environment. So we say, okay, we're not going to give you the actual street address of this person, but we'll give you their state, or we'll give you their suburb, or something which anonymizes them somewhat. But then someone's got to do that, and some system's got to do that, and there's got to be security around that as well.
Yeah, I think that's a good one, because that kind of it's a good segue into the whole machine learning space, because we spoke about the business use cases, we spoke about the data privacy thing as well. But I think also wanted to get into the whole building of I guess machine learning kind of a thing as well, and how security kind of gets involved in there, because this is definitely like the customer use case and day-to-day security folks are kind of finding this challenge as well. The whole machine learning lifecycle thing, that was an interesting term that I came across. And would you be able to explain what machine learning lifecycle is, and different types of machine learning, if there are any?
Oh gosh, yes. So yeah, right. So I mean, I guess we've talked at a high level there about sort of a typical kind of flow. You start out with data, usually vast quantities of data, put it through your algorithm, do your training, get your model, make your inference. What we will then find is that we can measure the effectiveness of that inference, and we can take the outputs of that inference and the results of that and feed it back into the cycle and start to refine our model, make it better. So we can make it more accurate would be potentially one thing. And I'm using accuracy in a very broad term there, just by basically meaning make it better. Accuracy is a specific term, but we can just make it better. The other thing as well is that situations change, right? So what we've talked about there with the retail sector, fashions change, people decide different things. So we can't just have one model that we've made 6 years ago still providing the same business value today. So again, that machine learning cycle just keeps having to go around to adopt and adapt and get more data in from other places and use the same data that we've been using and cycle it round and around. So it does mean that it's quite an intensive industry, if you like. So machine learning in general uses quite a lot of compute, and to constantly retrain takes quite a lot of compute and data flow and workflow to make that happen. So that is one of the reasons why it's quite different from software development, again, from the if-then kind of software development. I think that industry has done quite well. If you are a software developer, you know how it works. You turn up to work at a software development agency, they're using some kind of Git repository and some kind of pipeline, and they test it and they put it into production. And I'm being very simplistic about it, but that's basically what happens, right? And they might use different flavors of Git repositories, and they might use different flavors of pipelines, but essentially they're doing the same thing. And well, they should be anyway. And if someone who works in that, in shop A goes and works in shop B, then they will see a similar kind of thing happening. Machine learning, there are very different kinds of projects. There are different kinds of challenges. There isn't really a one size fits all for that. And I think we're still kind of catching up with what some of the possibilities are. There are lots of different solutions out there. They all require different kinds of security constraints and security controls, and processes. And it just makes it kind of complex, if I'm honest. I don't have a super good news story for you here that, do you know what, just get this service or do this and everything's going to be fine. Everything kind of has to be sort of treated on its own at the moment anyway, until somebody comes up with some standard way of delivering this stuff. So yeah.
Right, and it kind of goes in well with what Rama had a comment as well over here. Do we know of a standard best practice to begin with? I know it differs from use case to use case, but I want to understand the beginning. Actually, maybe before, there's another related comment. That's the one I was thinking of. My observation is that machine learning project starts with the problem and then moves forward, but security and privacy generally landed at the last or at the least stage, which kind of goes in what you were saying as well, because there's no set standard for this.
Yeah. Well, that's the age-old problem of security, right, as well. So that people get really excited about delivering a solution, and then someone says, and how are we going to secure this now? And so, yeah, we need to be thinking about security throughout, always. And I know that I don't need to persuade anybody on this podcast of that. So, but you're right. You start off with the problem that you want to solve. Actually, do you know, that's actually a really insightful point, and something that a lot of people end up sort of getting confused with machine learning as well. You don't, with machine learning, collect a large amount of data, run some machine learning, and see what happens. You do actually have to decide what it is that you're trying to achieve. What question do you have? Then you can figure out the areas of data that will probably be useful, but not necessarily, but probably, and then work at it from that way. So, and yeah, look, in a proper, robust environment, security of that has to be thought about from the beginning as well. And age-old problem. All right.
Yeah,
Trying to make
and
that
I think
happen.
to your point, another security thing that is worthwhile looking at is the data scientists that you work with. I guess how they would, and usually 9 or 10 times they're not employees of your company as well. So you kind of have to figure out a way to provide them access from outside they treat them as contractors, like quote unquote contractors as well. So there's that challenge of data as well, of access.
Yeah, that's a very good point, actually. I hadn't really thought of that so specifically, but you're right. I mean, it's if you're working on a very large machine learning project, you might find that you are struggling to find resources, right? So we know this is an industry. We are really struggling to find enough people to do the jobs right now. And we know that there is a huge problem coming, that the projections about the amount of machine learning that's going to be used in day-to-day application space in business and adding social value, all the rest of it, we don't have enough people currently going through the training processes to fill those roles. So huge problem, also huge opportunity if anybody's interested in getting into the space. So yes, to your point. So at the moment, yeah, lots of agencies would be used for doing that kind of problem, and yeah, giving them access to the data. At some point, you have to trust. And I know that's a problem, but you kind of just have to, right? So it depends how far you want to go, you know, whether you bring those people into a physical space that you control, and so they're being physically monitored. More and more, that's becoming something which just is a luxury that most people can't do. So having your data in a cloud environment makes sense on two levels. Like I've said before, the vast quantity of data means that you can afford to put it there. You also can afford to keep it there, and you don't have to sort of shuttle it around over networks all the time. Takes a long time. So that's good. But also you can put security controls around it and say, okay, well, here is an environment that you can actually use to interact with it. So we're not using tools on our actual local machine, but we're using IDEs and platforms in the cloud to do this, so that makes sense from many levels. And it means that you can at least put security controls around that part of it. Can you stop someone from taking a photograph of their screen? No, you can't. But and what monitoring can you put in place for data exfiltration and the rest of it? There is some, but at some point, yeah, you're going to kind of have to trust your data scientists.
Yeah. There's no data leakage prevention or data. Yeah, it's a hard one. And to your point, so a lot of the questions are not even being asked as well. So you don't even know there are problems at this stage, because at this stage, a lot of people are focused on building the algorithm that helps in machine learning, rather than, because it's all about, let's get the data, see what we get, because this could be an experimental project to begin with. there would not be anything that comes out of it which is useful. So it's definitely an interesting point. Quickly addressing one more comment that came through as well. Evening all, love the stream, love Mike Chambers. Martinez is based out of the UK as well, by the way. Sorry, I was away for a few months. Dive deep into Web3, crypto, and NFT world. Oh my God, man. We're talking about AI machine learning. Martinez is already on Web 3.0 and
Web
NFTs.
3,
So.
excellent, fantastic. Send some our way.
Yeah, fair enough. Kind of like now, kind of going back to the Rama question as well. So we spoke about the data. We spoke about what people do with it in the business use case context. We spoke about the life cycle as well. Now, I want to kind of take a step back and go, okay, I'm ready to build one. You've sold me the idea for machine learning. Excellent. What are some of the, I guess, if I'm trying to build this from into, I guess, an AWS environment, what would be some of the components? Obviously, I would require data, but what are some of the other moving parts that people should think of, which is a good standard practice as well, which kind of goes into what Rama was asking here. What's standard practice and where do I start and what's something that happens in the beginning?
Okay, yeah. So, well, let's talk about AWS services, right? So there are some AWS services which are sort of clear and obvious candidates for this kind of thing. It's also kind of what I know about. So yes, there are going to be analogies with this in other platforms and places, but as I've already described, I think cloud works really well for this generally. And AWS have obviously got some services which work well in this space. So the first one is S3. So storage, data, that's what you need. So when I'm talking about data, we're talking about at the very least terabytes or petabytes of data for a real commercial high grade model. You're talking about as much data as you can get usually. So storing it somewhere really cheaply, like S3, makes a lot of sense. And also with S3, you've got the security controls in place there as well. So you can prevent people from being able to get access to it from the outside world, and you can allow your applications on the inside of your AWS environment to get access to it. So it's fairly well understood and fairly well known. And I'm sure that if you're talking about AWS more generally in terms of security, then that's not the last time we've heard about that. Then it's about how can we actually process that data in cloud. Now, there's oodles of different ways that you can do that, right? So I'm not going to list them all out. The one that I'll point out straight away, though, is, and probably what talks mostly to the kinds of workflows that we've been talking about as well, is SageMaker Studio. Now, SageMaker is an entire collection of tools and APIs and documentation and code samples and all kinds of things and containers that help data scientists and machine learning engineers to actually leverage cloud and leverage AWS cloud and be able to take the code that they've already written and add to it to make it cloud scale relatively easily. That's kind of what SageMaker is. A lot of people get a bit scared away from it. I totally understand that because they look at other AWS services like S3 and say, what does it do? It stores things. Excellent. I get it. Yeah, I know. And if the S3 team is watching, then I understand it's much more complex than that under the hood. But essentially, it stores things. EC2, what does it do? It's a server. We get it. So you can understand these things. You go to SageMaker. Actually, it's many things. It's not really a service. So when people peel the lid open on it, they look at it and go, "That's too complicated," and they put the lid back. I'm encouraging people not to do that. Just take the bit which is useful to you. Anyway, there's a wider conversation there about machine learning. I want to come back to that point, but so inside of SageMaker, there is a service, a thing called SageMaker Studio. And what that is a Jupyter Labs environment, which is fully managed and allows you to be able to process data. It hooks nicely into existing AWS services. So this is the environment that you can use that's fully hosted in cloud with your defined security controls around it. And you can allow people to process data and interact with other AWS services and do what they need to do, but in a controlled environment. And I think if you were to start out with a machine learning project, and this is a machine learning project where you are building your own models, then that is a fantastic place to start. And you might branch off and go into other places, but that's a fantastic place to start.
And so, okay, so we have SageMaker, we have S3 bucket, and then in terms of because Redshift seems to keep coming up quite often as well, and I didn't mention Redshift, so I'm curious, is that not considered like a component that goes into this?
Yeah, so Redshift is your data warehouse, right? So this is your petabyte scale data warehouse, and if you want to, uh, so yeah, this is one of those things where there's 17 different ways to do the same thing. You have to decide which way you want to go. Now, from a Redshift perspective, I would suggest that if you're already using that data warehousing for, large scale analytics, and I'm talking large scale analytics, if you're passing through a million rows, then you're not big enough yet. But if you're passing through hundreds of billions or hundreds of millions of rows, then sure, then your petabyte scale, that's fine. You can start to use that to do your dashboarding and reporting and analytics and all that kind of stuff. Now, you can also bolt into that. That could be your data source, I suppose, for machine learning. Because of the way that machine learning is, this sort of model creation side of things, it's very asynchronous, right? It's an offline activity. So putting it into S3 is probably the cheapest place. So if it was in Redshift, you'd probably bring it out of there. The other place is EMR, so Elastic MapReduce. If you've got an EMR cluster, then there are, or because that's a Spark environment anyway, you've got Spark ML, Spark Machine Learning. And so you've got the ability to actually run machine learning workloads directly inside of EMR. And you can also link EMR into SageMaker as well. And you can also export data from EMR into S3. So there's lots of possibilities. So if you already have one of those things like Redshift or EMR, then sure, work at building in your machine learning workflow into that. Many places don't. So that's, I guess, why the default start is S3.
Right. Okay, cool. Yeah, because I think I definitely heard of S3 bucket. The whole, what's it called? A couple of companies were built on the whole concept of like, oh, let's build a data lake. And that's kind of like, that would be the step one towards doing some kind of a data algorithm. But I'm curious now. So if those are some of the moving parts from an AWS service perspective, if we were kind of, now most people over here from a security background, you kind of, you talk about from what are some other services in terms of networking, identity, compute, workload, things like that. What would some of the thinking over there at that point in time?
Yeah. So from that perspective, very much the sort of the out of the box kind of what AWS does. And I guess because I am the first person in this series on AWS, maybe I get to talk about this as well. So inside of AWS, how do you secure things in general? And that will also play to machine learning workloads. So the fundamental starting block is identity and access management. So you have IAM, and this is very much about controlling who in your organization has access into AWS. And it is somewhat about what services in AWS can talk to other services in AWS. There's a very rich policy-driven kind of ecosystem for being able to define what that security landscape looks like. So that's very important, and you can get very in depth with that. And you need to have some kind of process over that, I think, to manage that at a really fine-grained level. So that's that. Then on the actual workload side of things, actual servers running, doing things, which could be running machine learning projects or otherwise, we're talking about VPC, so virtual private cloud, which is essentially a network, and you get to define what that network looks like. You get to define public and private subnets. You get to define the routing, and you get to define sort of stateless firewalls that are configured to manage the traffic between different components inside of there. That's very important as well. So those two at the very, very base level. Above that, there are a million and one other options, of course, web application firewalls, that security monitoring, and also, let's bring it back to machine learning for a second, some interesting AWS use machine learning themselves to actually help enable some of the products and services that they have. One of them, for example, just pick one out, Guard Duty. Guard Duty is an intrusion detection system that works at the infrastructure layer, which uses machine learning, and they all say artificial intelligence, to monitor the metadata of traffic flowing around inside of your AWS account and look for potential compromise. So is there someone minting NFTs, if, for example, when that's not what you were planning to do? Or is there someone sending spam, or is there someone mining Bitcoin? They should be able to detect that kind of thing and alert you to the fact that we don't think that's what you're doing in your account. We think that's what's happening here. Have a look at this. So the use of machine learning there as an actual service. So you don't need to know anything about it. You just plug it in and use it.
Right, sweet. And that's a good segue into one of the questions that came in from Brandon. Mike, can you speak about a bit about Zelkova, the original use case, and where it's headed? So the AWS Zelkova, I think, what was announced in Zelkova and Trios were the two services for data security that were announced by Amazon. And I'm like, oh, I haven't heard about it for a long time, so I almost had to Google it as well. I'm like, oh,
well, you say
I
you
don't know if
almost had to Google
heard
it. I'm
anything
going to
about
say
it. I haven't.
I did Google it because I saw that in the chat, and I was like, honestly, not sure what that is.
Yeah, so
Maybe it's
if you
known
look for Amazon, AWS Zelkova, or AWS Trios, TIROS, there's an announcement made by them like ages ago, and I never heard anything about it after that. So, unless Brandon, if you have some information yourself, feel free to share it, man. But I think it was like an inside. It was a personal AWS project from memory, if my memory serves me right, which they
right.
were going to open source, but that never happened, or they were used by something some other software in the background. But Brandon, you can correct us if I'm wrong. And
so
if you have some
look,
insights.
I use AWS quite a bit, and it's not in my day-to-day vernacular for the moment. There are some other kinds of services that maybe spun out of this, but I wouldn't be able to hand on heart say that that's what it was. So I like it. It also appears to be some kind of plant, because I'm Googling what Zelkova is.
It definitely is. You can blame it on apparently most names of services in AWS are plants or animals or fishes or something. So
So it depends on the era. There's an entire conversation that could be had around that. You've got everything from you got your EC2 and S3, and then you've got your elastic beanstalk, and then you've got Fargate. So it's amazing. Yeah. I don't wish to try and overlay any kind of rhyme or reason to AWS naming convention. I just go with it. Just go.
Yeah, fair enough. Oh, so Brandon just came back as well. Nope, was nothing but hoping I think I don't think it'll be really interesting to hear if we actually hear anything about it in the future. But that was a great question, Brandon. Thanks
you know
for that,
what?
man.
It's every day from now on, I'm going to hear about this thing. I was like, that's what it was. Right, that's what we were talking about. So we'll have to come back.
Yeah, and Brandon, if you find out about, I'll love to hear about it as well, man. I think I've definitely been quite keen to hear about it. I've got another question from Pani as well. What technology can we learn from? So people who are starting off new, I guess, in the AI ML space. I would probably pin this for now because I've got this question right in the end as well. So I'll come back to this. Yeah, but before, because we were kind of going through the AWS components that were, I guess, involved in this, because to your point about the if-then world, where we have the whole CICD pipeline, we have all these other things that we turn on, guard duty and all that. So are they all still applicable from a machine learning project? I mean, I'm just thinking of a project like kind of what we spoke with the retail store. I just want to make a recommendation engine, and I've got a bunch of data from last 10 years in an S3 bucket. Are there components like CICD and all that gets involved in this?
So yes, there can be. Yes, I think to my point, like if you were to ask me, is there CICD for machine learning generally, I'm going to contentiously say no, but that's because there are many different solutions. There's not just one. There's different things. Like I think if you look at recent, and I say recent, I mean the last year or two, blog posts from AWS and also industry in general and service announcements and stuff, and you look for the word pipeline and something to do with machine learning, you'll find probably at least 4 completely different pipelines that can be used at different parts of the overall life cycle. And so you have to sort of choose the one that makes sense to you, or maybe choose multiple of them, because you can pipeline the data pre-processing, you can pipeline the training part, you can pipeline experiments. Because the other part to this, right, when I say, well, I glibly said before, an algorithm writes a model, that is such a gross oversimplification, right? So what really happens is the algorithm produces a model, it's rubbish, and we throw it away, and then we do it again, it's also rubbish, and we throw that away, and then we do it again. The process to actually train takes a long time because we're trying many different iterations of slightly different configuration options and stuff like that. So orchestrating that is a pipeline in its own right. And then you've got the inference side and pipelines there as well. So it gets really, really complex. Like, who knew machine learning was complex? So there's a bunch of things there. Now, inside of the SageMaker world, and if you look inside of SageMaker Studio, which kind of surfaces some of this stuff, you've got SageMaker Pipelines, which is essentially an API, a set of APIs that can help with the orchestration of that training process, that bit in the middle. And I think that's probably the closest thing, which is akin to what we're talking about in CICD. Sometimes these things as well are underpinned by actual pipelines, like code pipeline, which is essentially that CICD tooling that you can use in machine learning world as well. So there are bits and pieces like that. I do, however, want to take this problem space as well. Okay, so you're working in retail, you're wanting to build a recommendation engine. There are other ways that you can do it as well inside of AWS, without having to go to that level of getting into tweaking with algorithms and producing models. You can actually use pre-existing services. So there is a layer inside of AWS, which it's important to know that this exists from a security perspective, as well as practically speaking. There's this layer of what they call AI services. And I appreciate that I had this sort of thing about AI, but they call them AI services, and they call them that to differentiate them from the ML stuff that we've been largely talking about with SageMaker. And these are services which are API driven. And your if-then developer who has knowledge about being able to integrate with APIs, as they all would, can easily integrate with these. And so these can be secured by regular kinds of policy inside of AWS. And you can basically, in the case of Personalize, which is a service which does exactly what you're talking about, you throw a bunch of your data at it and you can get recommendations out of it. It's fully managed version of everything that we just spoke about. So you'd be it would be a sensible idea, especially at the beginning of the project, to see if that is suitable for what you need. There are a whole bunch of other projects like that as well for image recognition. So if you want to build image recognition into your application, then go and use the Recognition with a K service. Just throw data into it, throw images into it. You can go into the AWS console now and actually throw images into it, and it will give you a sample of the data that it would provide. Like, it's very interactive to see how it would actually work. Comprehend, text recognition stuff, or text-to-speech stuff, all of this stuff, it also exists. It's all ML powered, and all of the hard work's been done for you already. So if it fits your use case, you should probably go and use that.
Actually, that's a good one. I didn't realize there were services that were almost like a PaaS, I guess, for lack of a better word. There's platforms that are...
Exactly the right word. Yes, that's exactly what it is. And most of them actually are pre-trained machine learning models. So literally, I could take your image, I could put it into Recognition, and it would say, that it's a person. It would find your face. It would tell me that you're happy because you currently are, and it would give me an approximation of your age and all this kind of stuff. And it all exists already. So a whole bunch of pre-trained models. Take the audio from this podcast, stick it into Transcribe, and it would bring out the audio to text, like speech to text, then put it back into Poly and make it so that we've had a version of this podcast where all of our voices have been replaced by automated AI voices in a different language with Transcribe. So you can do all of these things just with pre-trained models that are just there. If you know how to use an API, you can bolt this into your application.
Wow. And because that kind of makes me even think that, are there AI services that, how a lot of people would have a lot of security logs to go through, and which
Mm.
to a large extent is pattern recognition or running queries on it as well. Where to your point, fraud detection could be kind of part of it. That hey, Ashish did a transaction from I don't know Australia. 2 seconds later, he did a transaction from India, and another 2 seconds later, he did a transaction from Scotland. Clearly, he's not moving that fast. So like things like that, I'm sure you can teach an algorithm. So are there services like AI services, quote unquote, that kind of you can I guess mold into security use cases?
If nothing else has come out of this podcast, the fact that you're going to say from now on AI services, quote unquote, that's perfect. But yes, in answer to your question, yes. So you have fraud detection service. There is actually a fraud detection service as part of those pre-trained models where you can supply it your data and it will analyze that for fraud. Also, generally, the broad category is anomaly detection. So you're looking for anomalies in something. So you've got a bunch of services called Lookout For. It's fantastic naming. So you've got Lookout For Vision, where you can basically feed in images. And one of the examples they'll give with this is feed in images off a production line. And if one of the products coming down the production line has got a fault in it, a scratch on it, or it doesn't look like the rest, then it'll get flagged. It's just looking for something that looks out of place. You've also got Lookout For Metrics. So if you've got numbers coming out of something, which could be, latency times coming out of a load balancer, for example, then it can detect that anomaly. So lots of things which, and I just want to point this out as well. If anyone's sort of sitting there thinking, but I could do that, like I, as a person, I can look at metrics and I can find that. Yes, you can. But what we've done here is we're able to teach the algorithm, or we're able to produce a model, let's get the terminology right, to do this in an automated way at a scale that humans can't do. Can I teach you to recognize the difference between a dog and a cat? You probably already can. You're very good. But we can also teach an algorithm to do it, a model to do it, and get that done at a scale that we can't do because we are flesh and we like to go to sleep and the rest of it. So that's kind of where machine learning comes in. It's not at the point yet where it's going to take over the world and start a robot revolution yet. It'll get there. At the moment, what it's mostly about is automating things and making things happen at scale so that we can derive that value out of the data that we've got.
Interesting. So maybe another segue into this is because in most like if and then statement kind of life, there's usually only certain scenarios that are covered by AWS services from a security perspective, and you kind of have to go down the path of using open source tooling for doing some kind of security around it. Now, I don't know if these kind of use cases do exist in the ML world, but I'm assuming services from AWS are usually enough, or is there, because I guess that it sounds like SageMaker already covers the Jupyter part as well, so you kind of have that covered from there. So what are some of the open source tooling that you hear of in the ML space that people end up using, which is by gaps that are left by AWS?
Well, so in ML in general, it's full of open source, right? And everybody's using everybody else's open source software.
Right.
If people haven't heard of Jupyter Notebooks, by the way, and everybody hasn't heard of Jupyter Notebooks at some point, do yourself a favor and go and find out about them. Wiki pages of running code. There you go. Like, just, they're awesome.
Oh yeah, actually, that's a good way to put it.
You can use them. You don't have to be a data scientist or a machine learning engineer. You can just run Python scripts on your own machine. They're still awesome, right? So that's that. In terms of open source in general, you hear things like TensorFlow, PyTorch, MXNet. These are frameworks which are used for building machine learning projects. They're all open source and they're all heavily contributed to by the big players in the marketplace. TensorFlow is basically owned by Google. MXNet is highly contributed to and basically owned by Amazon, et cetera, et cetera. So the entire industry is powered by open source, generally making models. From a security perspective, there probably are some sort of niche things in there from those projects. But broadly speaking, yeah, the services that AWS have with those security things around it are fine. Where you would want to add to it potentially is if you want to managed more holistically. So things like IAM and CloudWatch and monitoring and guard duty and security hub, they all work nicely, but sometimes you want to wrap that up into something in a bigger context. Then sure, you start to look to other SIEM products. So if you've got open source SIEM products that you want to use, that's fine, or commercial ones that you want to use, then there's that element of it. At the fundamental level, though, I think the controls are there.
That's right. And to your point, it's fairly similar to, I mean, I don't want to compare it if then, because it sounds a bit kind of comparing apples and to potatoes, I guess.
And we also don't want to say that if then development is easy or anything. Like it's also, it has its own challenges, right? I hope that hasn't been how it sounded, but obviously machine learning is better.
Yeah. And so to your point then, how does the whole curve work for maturity in this then? Because I'm almost thinking that, oh, well, because a lot of us may have had little input into ML project. Some people may have been involved from end to end. What are some of the maturity scales for this, like a ML project, out of curiosity? Like what does level 1 look like, and what does level, I don't know, 25 look like, I guess?
Right. Yeah, sure. Okay. So context for this, it's really important. And I alluded to, I said I wanted to come back to this, and this is me now coming back to it. Machine learning is a huge topic. It's enormous. It is an entire slice of information technology. So when people lift the lid and look at it for the first time, and I'm not just talking SageMaker here, I'm talking everything, it's enormous and it overwhelms people. And that's because you have people at university who are standing at whiteboards and coming up with new ways of looking at data and algorithms and mathematics that will make my head explode. And I don't even understand what they're talking about. I don't even know the symbol that you just wrote, what that even means, that type of stuff. Wow. And then you've got all the way down to the way that you build silicon to actually make this stuff work. That literally is all of it. And everybody who works at those different disciplines is needed to do this, right? And I've had conversations with people who are professors at university who are wrangling around with algorithms that just make my head hurt. And I go, well, I just don't know how you do that. That's amazing. Thank you for doing that. And they look at me and there's you're putting algorithms to work on infrastructure at scale. And like it sounds ridiculous as I'm saying it. It's like, yes, I'm just using some web services and I'm making it happen. It's like I get it, right? Because it's what I do. But to them, what I do is amazing. What to me, what they do is amazing. I still think it's laughable, but anyway, I'm just using some APIs. But anyway, everybody is necessary in that chain. So in terms of maturity, what you were talking about, in terms of where you start and all that type of stuff, you as a let's say you're a regular developer right now, choose the bit which makes sense to you, the bit that interests you. Choose the bit which aligns to the business problem you're trying to solve. And if that's using an API service, then just go and use that because it's already built and you'll sort of get to see some of the capabilities, and maybe you'll want to move to a different part, but you could probably quite comfortably become an expert in using that and provide value to your business there. If you want to go deeper, then take someone's algorithm that's already been written. That's what most people end up doing in machine learning. There are well understood, well-known algorithms for doing classification problems, or for doing image recognition problems, or object detection problems, all that kind of stuff. Like, don't reinvent the wheel because it's been done already. Much like you do as a library of code, it's okay, it's not cheating, and this is what we do. You take one of those. You might want to extend it slightly, maybe, but otherwise just train your models from that. If you wanted to at some point, then sure, you can go and write your own algorithms, but you'll disappear into a black hole and you'll probably never emerge. But you can do that too. So there's all different places here that you can get involved, and there's all different places that you can start. But you'll need to rely on everybody else who's in the chain as well. Does that make sense? Does that answer the question?
It does. I don't know, it does. And I think it is to your point, it's a growing space as well. So
yes,
some of the challenges we may not have even experienced as well. To kind of like, hey, maybe there's another layer of maturity over here. We just haven't really reached that point yet.
Oh, and will we ever? Like, this very neatly comes back to the usefulness of AI. Like, AI is still a thing. We're still over the horizon. We're still constantly trying to strive for the next level of innovation. So,
Yep.
machine learning has been around since the 1960s. Like, people were like putting together things in the 1970s. They couldn't do very much because the computers back then were woeful compared to what we have now. So imagine in 5 years from now, with the increase in capacity and the thought that's been driven through all of the innovation which is happening right now, we are nowhere near finished. We started a very, very long time ago, and we have much, much more to do before we call this done.
Yep. Yep. And that's a good segue into Pani's question as well, and my question as well. So where does one start learning about this, I guess, space? What's a good place to start? I would love to shout out your course as well, but I'll let you do that.
Sure. I mean, if only there was a really good course about machine learning. Yeah, looks like I have put a course together about machine learning. Clearly, I'm going to mention that. And it's very much focused on doing machine learning inside of AWS, and also is there to try and help you get to certification level with that as well. So there is that. Outside of that, the real key thing is to pick the place that you're interested in learning in that area that I talked about in the vast quantity. If you're really interested in maths, then go to a university somewhere and get some books and enjoy yourself. And you have my full respect. If you want to do something more in this sort of ML ops space, which is probably more common and more popular, then there's lots of resources on YouTube as well. The thing I would suggest that you do is that you choose a project to work on yourself. Have a go at doing something yourself. Find something that you are interested in outside of the world of technology, potentially. So if you're interested in sports, or if you're interested in horticulture or something, then find something where you can get data yourself, that's data that you understand, and then put a machine learning project together around it. Try and make some predictions about stuff that you understand, because we've mentioned domain expertise back towards the beginning of this conversation. That's really important for machine learning projects. So if you're working on something yourself, then it's important to understand the data and then work around with it. Get some classification out of some data that you know about. That's how I started. I haven't talked about, I really enjoy image classification stuff because it's very visual, it's very impactful, and I enjoy making things out of Lego. And so my pet project, which is a continual theme in the background, is that I'm working on a Lego brick detection. I'm ultimately building a Lego brick sorting machine. It's an ongoing project. It'll probably never be finished because I'm constantly applying the new things that I learn and new things that industry comes up with to the concept of Lego brick detection. That's my thing. What's your thing?
Yeah, that's such a good way to put it. That was also the last set of questions that I had, and I've got a few people, quite a few people enjoyed it. So very insightful. Thank you both. As Rama, Sachin joined late, but you guys introed me to listen to the recording. Yeah, definitely worthwhile listening, man. Great session from Vineet as well. So this is kind of like towards the tail end of our section as well. We're kind of on the hour. 3 questions, not too many. So it's fun questions. You get to know us more. What do you spend most time on when you're not working on machine learning and AI and all that?
Well, wow. The easiest answer to that, which is probably the truthful answer, is everything else in AWS, which is honestly true. I'm an AWS fan generally. But other than that, look, I live here in Queensland. I live with my amazing family. We're one of those families that pre-pandemic we were already homeschooling. So we homeschooled so that we could travel, we could show the kids different parts of the world and stuff like that. So that's a huge part of my life outside of technology. But yeah, that's a bit about me. And drinking tea.
Yeah, that's an awesome answer. Next, what is something that you're proud of but is not on your social media?
Proud of that's not on social media?
Yep.
Wow. Pride. It's such a difficult thing to have, isn't it? Especially as an Englishman, right? What are you saying? Well, here's something that leaps to mind. We are, I said we're kind of into homeschooling. We do homeschool here. We also have connections into local community schools as well, and democratic education, which is a whole separate topic that we could have an entirely different podcast on. Yeah, over the last year, we've in this family, been involved with helping set up a democratic high school in my town, in my city. So that's been something which we're super proud of. And yeah, I tend to keep, so my social media profile is largely about me doing machine learning and technology, because there's so much stuff out there that if you're interested in following a particular niche, then you'll find it. And me telling you about my obsession with Rubik's cubes, which are constantly in my hand, or anything like that, there are way better places to look for that kind of stuff. So that's why you don't find that kind of stuff. It's not because I'm not proud of it, it's because I talk about one thing mainly.
Education is definitely an interesting one to be proud of, for sure. Last question: what is your favorite cuisine or restaurant that you can share?
Oh gosh, right, okay. I don't know if there's anything good. Brutally honest, really quick answer: I like Mexican food. And so anywhere where I can find some decent Mexican food. I've said before that I traveled around quite a lot, and so then I'm now going to say I've never actually been to South America. I'd like to at some point, and so whenever I go around, I like to try and find decent South American food somewhere, but different takes on it, right? I'm going to be honest with you. I like different cultures' takes on different cultures' foods, if that makes sense.
I know what you mean. Yeah.
Well, so Indian food's a fantastic example of this. I've lived in UK, say most of my life. Yeah, probably most of my life still at this point. I've been over in Australia for quite some time, and lived in London. Lots of great Indian food and food from around that area of the world in general, right? So not just Indian. And I am quite aware that is a UK westernized version of, and I like that, because I like what's happened there. I did go to the Curry Club on the Strand in London, which apparently is very authentic. And it was very nice. It was very different, but it was very nice, but very different.
But very in your face kind of thing as well.
Yes. There was quite a lot of sweat dripping down from quite a lot of people.
I know, and I think this is coming as an Indian as well. I think a lot of us definitely felt some. I'm like, wow, I didn't realize authentic can be this authentic. But it was definitely. I'll recommend the others to check out the place as well. But this was pretty awesome, by the way. I really appreciate you kind of hanging out with me, because I'm sure there's a lot more questions coming in, because Martinez kind of came back saying as well he enjoyed the session as well. Brilliant session. So where can people find you and connect with you on this?
Yeah, sure. So on social media is the best thing to do, of course. So LinkedIn is probably the best place. So if you look for Mike G. Chambers, on LinkedIn, that's probably the best. I am also on Twitter as well, but that's probably slightly more frivolous. If you are interested in sort of Lego brick sorting machines and Rubik's cubes, then that's probably where you'll find that. So LinkedIn's probably the best place. Also on YouTube as well, I should say that. I have a YouTube channel which has got quite a lot of content, which was put together, streamed a lot during reInvent, with reInvent announcements. Prior to that, we did an entire series where we actually built a machine learning project from scratch, using basically live stream input as to, well, what do you want to build? Okay, let's build this. And actually, that's what it was called. Let's build something, I think is what it was called. And so we went all the way through and it built an image classification algorithm and full-on web app, essentially, by the end of that. All the code's up on GitHub if you want to follow along with that. Look out for more stuff in that space and more stuff to come this year.
And I'll leave a link for that in the show notes as well. I think our final comment from Martinez: I missed getting live session. Very happy managed to get a big plus. It's AWS month. Also brilliant to hear Mike Chambers live also. So thank you both. He's definitely been following your content. So I'm sure you'll hear from Martinez soon as well. That was all we had for this episode. But thanks everyone for your time. And we'll talk to you in the next weekend's episode of AWS Security. But thanks, Mike. Hopefully we can have you again. But really appreciate you hanging out with us.
That'd be fantastic. It's been an absolute pleasure. Thanks very much, Ashish.
Thanks, Mike. Thanks everyone else as well.